Hi, um, this is a very interesting questions from complex analysis, and it requires the application of residue calculus, residue theorem to find out the value of A. So if f is a function of the form h by k, where and if you have a singularity at z0, then so there is a theorem which says that residue of f at z0 is equal to h of z0 divided by k0 of z0. Here one thing we need to remember that h of z0 is not equal to 0. Okay, and k of z0 is equal to 0 to apply this theorem. So here what we have is h of z equal 1, k of z equal z square minus z plus a. Okay, so k dash z is 2z minus 1, right? 2z minus 1. Okay, so now so what is the region? So the region is unit circle centered at I. Okay, so this is the region. So we assume that there is at least one root of, so one of the point, so we assume that at least one of the point is inside this circle, so then only we can apply this residue calculus, right? If both 0 are outside of this circle, then the integral will give 0, right, from the Cauchy's theorem. So we assume that at least one of them is inside this. So from this formula what we get is integral dz by z square minus z plus a is equal to, from the residue theorem, is 2 pi I times h of z0 by k dash z0, and it is given that this is equal to pi, right? It's given that it is equal to pi, so this implies that 2 pi I h of z0 is 1, k dash z0 2 times z0 minus 1 equals pi. This implies, so pi and pi gets cancelled, and what we have is 2z0 minus 1 equal 2 times I, right? 2 times I. This implies z0 equals 1 upon 2 plus I. Okay, so what does that mean? So this z0 1 upon 2 plus I is a root of the is a solution. So 1 upon 2 plus I is a solution of z square minus z plus a equals 0, and we know that the complex roots turns in with conjugate, so we can easily see that the half plus I, this lies inside half plus I, So this half plus I lies inside this circle, and the complex conjugate half minus I, which is outside of this region, right? uh, so so what do we have? So one root is half plus I. So another, the roots of the uh, quadratic z square minus z plus a, that is equal 1 upon 2 plus I and 1 upon 2 minus I, right? So and so from the so we can now we can calculate the value of a. So a is nothing but the product of the, so a will be the product, a is nothing but the product of these roots, right? Which is just the Bezout's theorem, if you want to say, give a name. So this is equal 1 upon 4 minus I square, which is equal 5 by 4. Okay, so this was very interesting questions from the application of residue calculus, residue theorem. So the answer for this question is 5 by 4. Alright, thank you.